Hello viewers, I'm Kausalya. Today we are going to discuss problems related with star and delta networks. The problem is three identical coils each having a resistance of 20 ohm and reactance of 20 ohm are connected in star and delta across 440 volt three-phase supply. Calculate for each case line current and reading in each of the wattmeters connected to measure power. So here, what are all the given data? Here the value of resistance per phase and reactance per phase is given, and it is a 440 volt supply with, that is, three phase 440 volt supply. So here we need to calculate the values of line current and reading of the wattmeters when it is connected in star, right? And the second connection is delta. So here the thing is, first we are listing out the given data. So resistance per phase is, it is 20 ohm and reactance is again 20 ohm. Therefore, what about the impedance per phase? It is nothing but square root of 20 square plus 20 square. That gives the answer of 28.28. And the next thing is cos pi. Cos pi is nothing but R by Z. So we know the value of R, we know the value of Z, and here it is 0.707. Right, and finally the value of pi is nothing but it is 45 degree. Now we are proceeding with the star connection. So here in this case, regarding a star network, as we all know, the value of line current is equal to phase current, whereas the phase voltage is EL divided by root 3, right? So here the line voltage value is 440 divided by root 3 gives 254 volt, and the value of line current IL is nothing but, that is, which is equal to I pi, and I pi is nothing but E by Z. So here the value of E is 254 and the value of impedance is, we have already calculated, it is 28.28. So just substitute the values. Here we are getting the answer as 8.98 amps, right? Now we are going to find the readings shown by the wattmeters, right? So here the general thing is, the wattmeter reading is, it is nothing but the power, right? It is measured in watts. So here it is given by ELIL cos 30 plus pi. This is the reading which is shown by 1 wattmeter. So here we know the value of EL, right? EL is the value which is directly given in the problem. Therefore it is 440. The value of IL we have calculated, and even the value of pi is 45 degrees, right? We have already calculated. So just substitute the values, and here the answer is 1023 watts. Now we are proceeding with the next step, that is finding the value of reading shown in the other wattmeter. So it is given by ELIL cos 30 minus pi, right? So here we know all the values, so just substitute them, and as we all know, cos of minus theta is nothing but cos theta, right? It is a plus value. So here 30 minus 45 will be minus 15 degree, but cos of minus 15 is nothing but cos 15. So again here the value is 3817 watts, right? That is a shortcut to check whether the obtained answer is correct or not. So here in this case, the value of P is given by root 3 ELIL cos pi. So here just substitute the values, we are getting 4839, right? And similarly, when you add the values shown by the wattmeter, right, 1023 plus 3817, we almost get the same value or some nearer value, right? So here when you add this, we will be getting the answer as, it will be 4840 watts, right? They are similar. So the first part is over. Now we are going to proceed with our second part. So delta connection. So the delta connection, as we all know, E pi is equal to EL, which is nothing but 440 volts, right? So in a delta connection, the line voltage is equal to phase voltage, but the line current is root 3 times of phase current. So we are calculating the phase current. So E pi by Z pi, the value of E pi is 440, Z pi we had already calculated. So here the answer is 15.56 amps. Now the next thing is IL, the value of IL is root 3 times of I pi. Therefore root 3 into I pi gives 26.95 amps. So again now we are going to calculate the value of W1 and W2. So here in this case the W1 is, you see, ELIL cos 30 plus pi. So here the value of pi we have already calculated, ELIL just now we have calculated, right? So substitute it, and here the answer is 3069 watts. Again for W2 the value is ELIL cos 30 minus pi. So again just substitute it, and here the answer is 11454 watts here, right? And finally, to check, again we are using the power formula. Here the P is root 3 ELIL cos pi. Again just substitute the values, that gives the answer as 14523 watts. So here when you add the readings shown by W1 and W2, it should be almost equal to this value. So again when you add this, we are getting exactly the same value here. Okay, this is a method just to check whether the obtained answer is correct or not, right? So this problem gets over here. We will proceed with the next one. So the next problem is a 3-phase 440 volt supply feeds an unbalanced delta connected load in which the value of the impedances, right, ZRY, ZYB and ZBR are given, and here the phase sequence is RYB. Find the readings of the 2 wattmeters which are placed in R phase and Y lines for the measurement of 3-phase power. So here you see 2 wattmeters are placed, right? One is placed at R and another one is placed at Y. And here the supply voltage is, it is a 3-phase, again it is 440 volt, right? And it is a delta connected load, right? It is clearly mentioned in the problem. So just draw the delta connected load, and here the wattmeters are connected in R phase and Y phase, right? And that's it. IR, IY and IB are the line currents, right? And here they are the respective phase currents, IBR, IYB and IRY, right? So now we are going to find the values of reading shown by the wattmeters, right? So here the first thing is we are taking the RY as a reference, right? Here the phase sequence is given as RYB, right? It is given as RYB. So RY, YB and BR. So we are taking VRY as reference, therefore 440 with an angle of 0 degree. So VYB is 440 minus 120 and VBR is 440 with plus 120, right? So here the next thing is we are going to calculate the value of IRY, IYB and IBR. So IRY is nothing but VRY divided by ZRY. So VRY we know the value and ZRY is directly given in the problem, you see, right? ZRY is given in the problem. So therefore just directly substitute the values, right? Substitute the values, and here we are getting the answer as, we can directly solve this, right? When both are in polar form, just like 440 by 20 gives you 22, and 0 when you move this minus 30 to the numerator, it becomes, sorry, plus 30 to the numerator, it becomes minus 30. So 0 minus 30 gives you minus 30 degree, right? So similarly in the same way you proceed with IYB and IBR, right? So just substitute the values and find the answers, IRY, IYB and IBR. So the next step is we are going to calculate the value of IR and IY, right? So again when you look back at the diagram, we have to calculate IR and IY, right? Because only in these two lines we are having our wattmeters connected. So again when you apply KCL, okay, consider this junction. So how will you apply KCL? Sum of currents flowing towards the junction is equal to sum of currents flowing away from it. So here what are all the currents that flow towards the junction? IR and IBR are flowing towards it and IRY moves away, right? So the same thing I had written here, right? IBR plus IR is equal to IRY, but I need only IR. So IR is nothing but IRY minus IBR. Again, just substitute the values. In the polar form, we can't do addition and subtraction, right? So convert each polar form into rectangular form, and here the value of IR is this one. Similarly, again, when you apply Kirchhoff's current law, right, we can write the expression for IY. That is, again, when you look back at the diagram, so look at this junction here, this. Therefore, the current flowing towards the junction is IY and IRY, and IYB is the thing that flows away. Therefore, IY plus IRY is equal to IYB. So this is what I had written here. So again, we need only IY. So IY is given by IYB minus IRY. So just substitute the values, again convert it into rectangular form, and here is our final answer. Again this is converted into polar form, right, just for our simplification. So the next thing is the reading shown by the wattmeter, right? So here again, this is the expression, right? That is reading shown by the wattmeter which is connected in R phase is given by VRB IR into cos pi 1. Similarly, the wattmeter connected in Y line is given by VYB IY into cos pi 2, right? So here just now we have calculated the values of IR and IY. So the rest of the thing we need to calculate, that is VRB, VYB, and similarly cos pi 1 and cos pi 2. So here you see VRB can be written as minus of VBR, right? Because we are reversing the phase sequence. So there is a minus sign here. So in this case, you see, so the value of VBR is 440 with an angle of 120 degrees, right? So here there is a minus sign. So this minus sign, you see, this can be written as, this minus is nothing but minus 1, right? So this minus 1 is nothing but j square. A single j contributes an angle of 90 degree. Therefore, j square will contribute 180 degrees. Right. So instead of this minus 1 here, I am writing it as magnitude of 1 with an angle of 180. So when you add 120 and 180, that gives an angle of 300 degrees. Right. So the next one is calculating pi 1. So here when you calculate pi 1, you see the pi 1 is nothing but it is the angle between VRB and IR. Right. So here the angle of VRB is 300 degrees. What about the angle of IR? You see, the angle of IR is, it is minus 30 degrees, right? So here the thing is pi 1 is nothing but 300 minus of minus 30. So finally this gives an answer of 330 degrees, right? Now the next thing is we are going to write down the value of this WY. No, we have just find out the values of VRB, IR and pi 1, right? We will find out the value of WR. So here just substitute the values and here the answer is 16804 watts, which is nothing but 16.804 kilowatts, right? Now we will proceed with the next one. So VYB. So in VYB is nothing but 440 with an angle of minus 120. And IY is 31.2 with an angle of minus 165. So pi 2 is the angle between these two. So therefore minus 120 minus of minus 165. So that gives the answer of 45 degrees. So WY is nothing but magnitude of VYB, magnitude of IY and cos of this pi 2. So just substitute the values and here that gives the answer as 9.707 kilowatts. Therefore, the reading of the wattmeter which is connected in R phase shows 16.8 kilowatts and Y phase shows 9.7 kilowatts. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.